Welcome, everybody. We're super excited to have you with us this evening. My name is Christine Curry, and I'm the host of our Watershed Talks. It's a program with the Iowa division of the Izaak Walton League of America. And this evening, we have a fabulous presentation called Vanishing Wings, a wake-up call for nature, how neonics threaten our insects, aquatic life, and more. This evening, we have the privilege and opportunity to meet with Mike Miller, a stream ecologist. He's from the Wisconsin Department of Natural Resources. And just a little bit of background about Mike. Hold on, I'm still, Chris Henning is our co-host. I think she may be just transferring over to another device to help us out this evening.
Oh,
So hold on. And if you could just unmute yourselves, that'd be great. Um, Mike is a stream ecologist, as I mentioned, with the Wisconsin Department of Natural Resources in Madison, focusing on stream and watershed assessment, neonic contamination, and innovative technologies like UAVs for stream research. He also co-authored a field guide to Wisconsin streams, and he teaches at the University of Wisconsin and collaborates with citizen scientists. In his free time, he enjoys fly fishing in Wisconsin's Douglas area. And fantastic. So this evening, we do have a little bit of a technology glitch. Mike's microphone is not working. So I have him on my phone. So you're going to hear him, but he is going to be on my phone and he has his presentation up. So Mike, I think you're good to talk and introduce yourself.
Very good. Thanks, Christine. I appreciate the opportunity. And as Christine mentioned, we've got a slight audio issue here. So if you're having problems hearing me, just put a note in the chat and I'll make certain I speak up. So again, thanks for inviting me. Again, I'm a stream ecologist. I spent decades studying the streams in the state of Wisconsin, and for about the last 5 or 6 years, I've been focused on the issue of pesticide contamination in our streams and rivers. And I've worked on this issue with both in the state of Wisconsin and also with the U.S. Environmental Protection Agency at a more of a regional and national level. So neonicotinoids doesn't exactly roll off one's tongue, so I'll probably use the term neonics just for a definition. Neo meaning new, and nicotinoid meaning, so in essence, it means new nicotine products, and that's exactly what they are. But I'll kind of go through that in more detail in a little bit. Perhaps an alternative title for my presentation could have been, "Where Have All the Insects Gone?" Not that long ago, certainly within my memory, truck drivers, farmers, people driving regular automobiles used to put window screening on the fronts of their vehicles in front of the radiators to prevent them from being plugged up with insects. And now I don't see that problem anymore when I look at trucks and vehicles, that sort of thing. And some people say, well, that's because our vehicles are much more aerodynamic. And I get that, but I personally drive a 1990 Volvo 240, and among Volvo enthusiasts, they're known as Swedish bricks. So my point being, my car is about as aerodynamic as a chest freezer. So at least in my experience, this idea that we're not seeing squashed insects on our vehicles is because of changes in design. That, again, is not my experience. The common question among from the public I get is, so what good are these insects anyway? And ecologists, biologists, we oftentimes use the term ecological services. What services do these organisms or plants, animals, whatever, provide to us humans? And so if you remember back to your 6th grade biology class, that green plants are powered by sunlight. They're the primary producers, which in turn are fed upon by some of the primary consumers. And my example in this graphic is insects. So they're, very key link in the food chain. So at a minimum, recognize that insects really drive a lot of our food chains globally, but also recognize these animals have all sorts of benefits to the environment and to humans. You can think of pollinators. People automatically think about honeybees, and they're actually exotic species from Europe, but there's dozens and dozens of wild species, native species of bees that pollinate plants. As you can read here, a lot of these insects disperse seeds. And I'll back up and say ants are key pollinators of many plant species as well. But the list goes on here as far as how they benefit the environment. So the fact that we're losing these animals is of concern. And in my world of studying streams and rivers, it's painfully obvious to aquatic ecologists that particularly the insects that live as an immature stage in the streams provide food for a lot of different animals. And then when they emerge as winged adults from the streams, rivers, and lakes, they provide food for, again, a long list of different animals that rely on these aquatic insects. So there's three things, or maybe four, I want to cover tonight. One is, so what's the concern about these declines in insect populations? I'll try to make the case for that. Then I'll get into the details on how neonics are used and what risks they pose to the environment. Then I'll just share some results from some monitoring work I've been doing in the state of Wisconsin. And then I'll touch on, this is not my world, but I'll offer what little I know about policy on neonic usage in the United States and globally for that matter. So what's the problem? Well, again, these declines are fundamentally important because, as mentioned a minute ago, these animals are key links in the food chain. So you don't need necessarily understand these plots or read them in great detail. If you just look at those trend lines going from left to right, they show declines over time. So whether it's species of insects or the total weight or biomass that are found in the environment, those sorts of things. So the few published papers that are out there, and again, these animals have not been tracked very closely, sad to say, with the exception of a few European studies. But the point being is we're seeing dramatic declines in our insects, whether they're aquatic insects or terrestrial insects. So, and again, the implications.
If I'm in trouble, run down to the firehouse and ask for help.
Sounds serious. Are you hurt? Okay. If you guys are about to play doctor, please leave me out of it.
What?
So,
Sorry about that. Please mute if you're coming in. I think we're good now.
okay, very good. So anyways,
Thank you.
point being is we're seeing declines in these animals, whether it's in Europe or the United States. Again, we have fairly weak data for the United States, but again, we are seeing declines. They have been documented recently. So why are we seeing these declines? Well, usual suspects are listed and are offered. What you're seeing in that first bar chart on the left shows the usage of these neonicotinoid insecticides in the U.S. So you see this dramatic increase from 1994 through 2014. And I'll get into this a little more detail later, but these particular type of pesticides first became commercially available in the early 1990s. And I'll touch on this later, but they're now the most widely used insecticide globally. So not only in the upper Midwest, but in the United States and across the planet. So again, these ideas that insecticides, habitat loss, and climate change all have an effect on insects. So again, I live in Madison, Wisconsin. We didn't get a lot of snow this past winter. Actually, I took this photograph last June. What we're seeing here is an emergence of mayflies on the Mississippi River. So give you a feel for how impressive or extensive these emergences can be. And I'll get into some details on that in a minute or two. So again, this particular species that's found in the Mississippi River, they extend from Minnesota down through Wisconsin, Iowa, into Missouri. So they kind of dominate the insect life in the Mississippi River. And as a result, they're really a key link in the food chain for the Mississippi River and for all those terrestrial environments when these insects emerge and drift over the landscape. So what you're seeing here is a Doppler radar time loop, and you can see from it's from 9 to 11 p.m. That kind of squiggly line in the middle is the border between Minnesota and Wisconsin, so i.e. the Mississippi River. So what we're seeing here is an emergence of mayflies on the Mississippi River occurring in one night. And again, they're hatching out in such great numbers that they're showing up on weather radar. And researchers recently, the Stepanian and others, have used this radar to actually track and quantify the numbers of mayflies emerging from the Mississippi River. So again, based on their studies, they estimate upwards of 20 billion with a B mayflies emerge from the Mississippi River during one of these 2 or 3 hour emergence time periods. And again, these occur multiple times throughout the summer. Maybe 6, 8, 10 different major emergencies like that. So again, each time this occurs, billions of mayflies leaving the river and flying across the landscape. So they're not staying on the river, but will move inland for many, many miles. And this represents a very significant food source for a lot of different animals. Again, these feed birds and bats and spiders and mammals. The list goes on. And Stepanian and others go on to report that these emergencies can make result in upwards of, as you can read here, 100 tons of insect biomass leaving the river during that one evening time frame.
Wow.
And they've also gone on to estimate that this represents trillions of calories of energy, a key food source for a number of different animals that actually synchronize their mating and the birth of their young and take advantage of these food sources. But disconcerting part of their study is based on this time frame between 2012 and 2019. They've seen a very dramatic decline in the emergence of the Hexagenia mayfly. And I didn't capture it on this slide, but they estimate that upwards of, if all these insects were eaten by birds, they could feed 50 million birds from when they nest or when they hatch to when they fledge. So a tremendous food source for animals, not only birds, but a number of different species. So what are neonics and how are they used and what risks do they pose to the environment? I want to back up and say that, when I speak to farm groups and others about these chemicals, there's this recognition up front that there's a number of different pests that we need to, and pathogens that we need to manage with chemicals. So I'm not saying we should not be using pesticides, insecticides, fungicides, herbicides. That's not the case, but I think I could provide a very compelling evidence that the current use of neonics are frankly not benefiting ag producers. So how do these neonics come about? Well, many of you recall the chemical or the insecticide DDT. Again, as you can read here, is developed in the probably in the 1950s into the 60s, but by the 1970s they're banned. And for those of you that are old enough, recall that we're seeing a loss of some of our high-profile bird species like bald eagles that were failing to hatch young because their eggs are being thinned by the exposure to DDT. So DDT is very toxic to not only insect life, but other animal types, and they are also tended to accumulate in the environment. So there's a push to come up with new types of insecticides. And so the next generation of insecticides were these organophosphates. And they too are highly toxic, not only to insects, but a number of different invertebrate species, including mammals. And so that kind of opened the pathway for developing the neonicotinoids. Again, they're advertised as being much safer, and to some extent that may be true. Again, they may be safe for vertebrates, mammals and birds and that sort of thing. To some extent, although the science is kind of changing our perspectives on that, but they're highly toxic to insects, and not just the pest species that we're trying to deal with in our crop fields, but for their broad spectrum pesticides. So they don't necessarily target certain pest species, but all or the vast majority of insects are impacted by neonics. So it's not just the aphids and other pest species, but it also is affecting butterflies and bees and the tens of thousands of other insect species that are beneficial to the environment. So as you can read here, there's synthetic versions of nicotine compounds. In nature, certain plants, as you can read here, like tobacco and tomatoes and potatoes, they all produce nicotine naturally, and that it helps them, these plants, ward off pest species like the aphids we see feeding on this plant leaf aphids. They suck the phloem or sap out of leaves in plants, and so again, they can be detrimental to native plants as well as crop plants as well. And again, we've commercialized or synthesized these chemicals to apply them to our crop fields. And for when humans, we smoke a cigarette or chew some tobacco or smoke a cigar, whatever, we ingest nicotine and we get nervous stimulation. But insects are extremely sensitive to these chemicals. And so when insects are exposed to nicotine, results in paralysis and death. So it should be recognized that by far the greatest use of neonics are on seed dressing. So again, the chemical producers and the seed producers, they coat the seeds with neonics prior to selling the crop seeds to ag producers. So this is primarily true for corn and soybean and wheat and a lot of the other grain products and potatoes and other vegetable crops as well. So by far and away, the major use of neonics in the United States and probably globally is as a seed dressing. So frankly, in the United States right now, you can't even buy field corn seeds that are not treated with neonics, and roughly about 65% of the soybeans are pre-treated with neonics prior to selling to the farmers, even producers, even though they may or may not have any risks of pest problems. But there are also other applications as well. They can be sprayed on fields after the crops have grown to a certain height. They're used in urban settings and in golf courses elsewhere as granular applications where, again, the neonics are spread on the turf to manage certain turf species. So we see in our urban areas as well, it's not just an agricultural issue, but an urban issue as well. We're seeing high concentrations of neonics in our ground and surface waters in our urban areas as well because of these applications, whether it's in horticulture or ornamental plants or managing turf, ball diamonds and soccer fields and other green spaces. They're used for root drenches. So if you have issues with problems with like emerald ash borers is a good example where in urban areas they'll pour these neonics around the bases of trees and they're taken up by the trees because these chemicals are water soluble and they get distributed through the tree, and that wards off pest species like emerald ash borers. They're using baits in urban areas. They put them on like sugar baits to control ants and cockroaches. And they're also using topical applications. You can think of your pet flea collars or the other chemicals you may apply to the skin of your pets, and they're used as topical applications for livestock as well. At least in the state of Wisconsin, hundreds of different products are labeled for use that contain neonics. So again, just to reiterate that nearly 100% of all the field corn seeds sold in the U.S. is pre-treated with neonics. So again, irrespective of whether or not the ag producer wants to use these chemicals, they're it's kind of baked into the economics of this, where they have to buy seed with pre-treated with neonics, and again, high proportion of soybeans as well. And I'm not starting to break down for wheat and oats and other grain products, but the seeds of those crop species are treated as well. So ag producers see some benefits to that. Again, they're busy through the cropping season, so if they the thought being is if I buy these seeds that are pre-treated with neonics, they're going to knock out those pest species. So that's one less thing I have to worry about. I don't have to go out and monitor my crop fields, so I can kind of check that off my list and get at busy concern myself with other work that needs to be done during the growing season. So the ag producers, they work on thin margins and they're very risk adverse. So again, they see this as kind of a cheap insurance policy. I'll buy these seeds that are treated. I haven't really had any pest problems in the last 15 years or the majority of my fields, whatever. But again, if I did have a problem, that might cause me some economic distress. So I'm going to use this as an insurance policy. So it's interestingly enough, there's been some recent studies that when egg producers are asked, what are on the seeds that you buy? And, as you can read here, a significant proportion of egg producers, frankly, really don't know. It's not like they're chemists or toxicologists and don't have a ton of time to spend reading up on what's on these on the seeds. They take the word of the crop consultants, and they see the commercials on TV for certain corn brands that guarantee great yields, that sort of thing. So again, they're using chemicals that frankly have no idea what chemicals they are using on in their fields. So the unfortunate situation here is now that I use the term prophylactic and use something that may or may not be needed. So back in the day, not that long ago, about 25 years ago, many ag producers were using principles called integrated pest management. And I'll list these here where, again, instead of growing corn or soybeans continuously year after year on the same plots of land, they'd rotate their crops so that would reduce the amount of pest buildup in their fields. Another thing would be to, frankly, monitor for pests. And if you did see a pest outbreak that reached a point where it might cause economic harm, then you'd go and treat the fields. But again, now we're using this prophylactic method where we'll put the chemicals on the fields whether we truly need them or not. And again, this idea of, again, neonics are broad spectrum. They're very effective at killing aphids and wireworms and other crop pests, but they're equally effective at killing monarch butterflies and fireflies and those mayflies we saw on the Mississippi River. And interestingly enough, at least in Wisconsin, I think this holds true for much of the upper Midwest, was prior to chemical producers and the seed vendors selling these treated seeds, frankly, there was little request for the use of these chemicals on the fields, the neonics, but now it's being labeled as something. Well, it's a great insurance for your cropping, so you don't have a pest outbreak and lose money. And again, you're going to see increased crop yields. But the reality is, frankly, in the past, these chemicals are used very little. So I'll walk you through a time series. Imidacloprid is one of three major neonics used in the upper Midwest for corn and soybeans. So again, the dark coloration on this national map shows where these chemicals were used in high concentrations or used extensively. So again, these chemicals became available in about 1993. So again, this is what the usage looked like across the landscape in 1995. And I'll walk you through a time series from 1995 to 2015. So starting with 1995, moving on to the year 2000, 2005, 2010, 2015. So I think I'm kind of seeing a trend here. And again, this is just one of three major neonics being used. But frankly, the U.S. Geological Survey was the primary federal agency that was tracking the use of these chemicals. They stopped tracking these chemicals because getting the data on usage has become next to impossible. The U.S. Environmental Protection Agency is responsible for the registration of pesticides and usage in the United States. The chemical manufacturers have used, frankly, what I see as a loophole called a treated article clause, where, again, if you use pesticides on some article, and that could be like your green lumber that's treated to reduce rot from fungi, or when you have a kitchen sink sponge where they put bactericidal chemicals on that, so your kitchen sponge is not growing bacteria again on your kitchen counter, and those are described as treated articles. So the chemical manufacturers made the case with the federal government that we're applying these insecticides to the seeds, so it's no longer an insecticide. So that, to me, that logic is kind of mind-boggling, but the ultimate effect of that is we have little or no understanding of trends and uses in the United States since 2015 or 2014, actually. So what risks do these chemicals pose to the environment? I would offer today or this week is National Pollinator Week. So as you can read here, neonics are neurotoxins, so they affect the chemical or the communication of our nervous system in insects and in other animals. So again, they can have real profound effects ultimately resulting in death of many of our insect species. And using a honeybee as just one example. So here's a little fun fact that you should take home with you. Again, if you took a quantity of Neonics the size of a sugar granule, so when you pour up your packet of sugar and poured it in your tea or coffee this morning, just one of those little granules of sugar, if you had a comparable weight of Neonics of that size, that sugar granule, as you can read here, that is enough Neonics to kill 125,000 honeybees. Again, one little granule, 125,000 honeybees. And at this point, we have no idea how many tens, if not hundreds of tons of neonics we're applying in the landscape in the United States each year. And again, if you continue with that analogy, again, a sugar packet, depending on the ones you buy, might hold between 3 and 4 grams of sugar. Again, a comparable amount of neonics, as you can read here, is enough to kill 600 million honeybees. And again, it's not just honeybees, it's a whole host of different aquatic and terrestrial insects. So again, it's not just an issue of honeybees or monarch butterflies, but again, the thousands of insect species that live in our terrestrial and aquatic environments. Some key properties of neonics that you should be aware of or have some understanding of. One, they're water soluble. So the chemical producers and the seed vendors say, well, you coat the seeds with this stuff, and then when the seed germinates, it's going to take up that chemical and it's going to get distributed throughout the entire plant. And it's going to protect the root system, it's going to protect the stems, the leaves, and the fruiting bodies. Sounds great. It's good advertising ploy, but the reality is it doesn't work that way. I'll provide some evidence of that in a minute. So since they're water soluble, that means they're very mobile in the environment. So if you have a rain event, there's a lot of surface runoff that ends up in our surface waters, whether it's a lake, stream, wetland, river, whatever, and it also leaches into our water table as well. Again, these can be very long-lived in the environment. They break down fairly readily when exposed to sunlight. If they're in the soil or if they're in a turbid stream, again, they can persist for multiple years for that matter. And a key finding from some recent studies is, again, the vast majority of these chemicals, well over 90%, it's probably closer to like 96, 7% of these chemicals are not taken up by the crop plant. They wash off the seeds. And so once they wash off the seeds, they're going to end up in the soil or in surface runoff. So again, the ag producers are not benefiting by the use of these chemicals. Again, they have profound impacts to our, again, terrestrial and aquatic environments. So let's see, it was 63 years ago in 1962, Rachel Carson published her book, Silent Spraying. And here was a lesson soon, and she talked about the effects of using insecticides. So it's either a lesson that was never learned or is soon forgotten because we're using more insecticides, more pesticides, like again, including fungicides and herbicides than ever before. Again, that was in 1962. A mere 9 years later, at the original Woodstock in New York, Joni Mitchell had her breakout hit, Big Yellow Taxi. And in that song, she said, as you can read here, she extols the farmers to put away the DDT. Joni might be surprised to learn that neonics are thought to be somewhere between 7,000 and 10,000 times more toxic than DDT. So if we're concerned about DDT and that had a long history of impacting our environment, it pales in comparison to the toxicity of neonics. Also, in her refrain, in her song, she says, "Don't it always seem to go that you don't know what you've got till it's gone?" Well, the reality is we don't know what we have, and so we don't know what we're losing. It's been estimated, planet Earth, we've so far cataloged 1.2 million animal species, as you can read here. And it's thought that approximately 1 million of those are insect species, but the reality is we probably have somewhere around 8 million different animal species on planet Earth. We've just not cataloged them all. So frankly, we don't know what we have, so we don't know what we're losing. So, what typically happens with us humans is, we lose some of these charismatic mega fauna on the landscape, whether it's a black rhino like we see in this photograph or many other mammal species in particular that are birds that we kind of focus on. And, we mourn their loss for a few years and then it's soon forgotten. But the fact is we're losing, thousands, if not millions of different insect species that we don't even know exist out on the landscape, much less how they relate to the environment, what their importance is. So again, when we lose those animals, nobody knows it. It's kind of this hidden loss that nobody's accounting for. And again, just put these numbers into perspective. Again, roughly about 1.2 million animal species on planet Earth. There's thought to be somewhere around, as you can read here, about 5,600 mammals on planet Earth. In just beetles alone, there's 360,000 different species have been cataloged. So again, just by sheer ratios here, we can be pretty confident we're losing tens of thousands, if not hundreds of thousands of insect species that, again, we don't know they're out there. We don't know their importance to the functioning of the planet. Hopefully some of you have heard of E.O. Wilson. He was, unfortunately, died about 5 years ago now. He was a ecologist at Harvard University. He was the world authority on ants, and he wrote published a couple of books on ants, a number of different research papers. But I wanted to share this quote from E.O. Wilson, where, again, we tend to fixate or focus on those mega vertebrates like the rhino or some bear species or whatever, birds, whatever. But again, the reality is that these small animals that are under our feet that we know little or nothing about are as important, if not more important, to the functioning of the planet. And what I'm showing this animal in the photograph here is called a net-spinning caddisfly. Again, they're close. Well, this is the immature stage of caddisfly. It lives in our streams and rivers in Wisconsin, Iowa, elsewhere. And as a stream ecologist, I study these and other animals. I can offer with great confidence that in the streams in Wisconsin, particularly our trout streams, these particular insects make up about a third of the insect biomass in our streams. So if we lose these little animals, say goodbye to 30% of the fish biomass, 30% of the blue heron biomass, 30% of the northern water snake biomass, 30% of the kingfisher biomass, the list goes on. If we lose the base of the food chain, that's going to have profound effects higher up in the food chain. And again, this photograph is actually from an animal that's this insect, larval insect, immature insect living underwater. They're close relatives to moths and they have a silk gland like a moth. So what these guys do is they spin a little web, and that's how they feed, and organic matter flows downstream and gets trapped in their net. But more importantly to the topic tonight, if we lose these or the hundreds of other species that live in our streams or terrestrial environments, it's going to affect things farther up in the food chains. So these chemicals come at a cost to the environment, very significant cost, based on a large and increasing number of studies. So what benefits do grain producers get from using these chemicals on their pre-treated seeds? So there's an interesting study done by Cornell University where they compiled data from, I believe, 11,000 different journal article studies. And based on their gleaning of the literature, they concluded that, based on hundreds and hundreds of field trials, where again, during the studies, they plant corn that had treated seeds treated with neonics, and next to that, they plant corn that where the seeds are not treated. And as you can see in this pie chart here, that in 83% of the studies, there was no increase in crop yield when in these test studies when the corn was planted with treated seeds. And you can see here there's 13% of the test trials where there was an increase in crop yields. But interestingly, in that case, for those increases in crop yields, the yields tended to be very modest, and it didn't offset the cost of the chemicals themselves. So the point being, for corn, ag producers are not gaining any economic benefit. That's fundamentally important. Again, a very rigorous study. And similarly, they looked at soybeans and kind of very similar results where, again, a very high proportion of the test plots showed that there was no increase in crop yields for soybeans either. Again, hundreds of field trials, multiple states, a few Canadian provinces all involved in these studies. So again, pretty compelling evidence to show the value or the lack thereof of neonics as used as seed treatments. And similarly, a study that was led by the University of Wisconsin, but there's a whole raft of other top flight schools, including the Iowa State University, involved in the study. And they, in essence, came up with the same conclusions as the Cornell University study. So the point is, in both of these very rigorous, multi-state, hundreds of field trial studies, both of them conclude that neonics provide very little benefit to ag producers. So who's benefiting from the use of these chemicals? Well, and I'll back up a little bit. So why is that? Again, they apply the chemicals to the seeds. And what's being shown in this diagram, again, this Mortzinis et al., that was the UW-Madison and those 12 other top flight university studies. But again, that orange-shaped wedge or salmon-colored, whatever wedge on the left side of the graphic illustrates, represents the concentration of neonics in the seeds and how it declines over time from when the seed is first planted to when there's a seedling, and then as the plant grows and the chemicals are diluted within the plant themselves. If you note that purple or bluish colored bell-shaped curve or bell-shaped curve, whatever, that represents the aphid populations in our crop field. So the point is, by the time the aphids are found in great numbers in our crop fields where they have the potential to do damage, the neonics have washed out of those plants or been diluted in those crop plants. So again, these chemicals are not having a beneficial effect in ag production. Now, there's been a few studies that show that in southern states, at least for corn and perhaps soybean, I don't know the literature on that all that well, but point is, there's some thought that aphids, as one example, they do show up earlier in the environment in southern states. So those states might get some benefit from the use of neonics where they're applied to the seeds. But what has been shown in the upper Midwest and some eastern states and Canadian provinces, again, neonics are not providing economic benefit to those folks that are frankly forced to pay for those chemicals. And there's been some interesting studies as well that show that when you apply these chemicals in the fields, they actually can kill a lot of the native natural predators of aphids and other things. The ladybird or ladybug, whatever you want to call these beetles, are kind of the lions of our crop fields, and they're very effective at killing aphids. But again, if they get knocked out by the neonics, their predators, natural predators, decline. As a result, there's been studies showing increased outbreaks of pest species due to the loss of natural predators. So again, who's benefiting? This is a very crude, I don't put a whole lot of stock in this is just kind of a back of the envelope estimate I made. So it's a wild guess at best, but in the state of Wisconsin, we're spending tens of millions of dollars on these chemicals. Now, perhaps in a billion-dollar ag industry in this state and Iowa and elsewhere, those tens of millions of dollars may be small potatoes, but again, still money being spent that where the ag producers are not recouping benefits. So if they're dealing with razor-thin profit margins, presumably saving money anywhere you can along the way in that ag production is beneficial. So here's some of the key players that are producing these chemicals. Bayer Crop Science from Germany. There's their headquarters is in Germany, and then Syngenta. It used to be a Swiss company that was bought out by the China National Chemical Corporation. So these are a couple of the big players in the production of neonics. And I'll also note that, for example, the use of these chemicals are banned in Germany, where Bayer is their headquarters is situated, but it doesn't prevent them from marketing their products in the United States and South America and Africa. And it's a big business. You can see here the top four chemical companies that produce neonics, and this is their annual revenues for the production of pesticides. No, not just neonics, but this is the profits their economic revenues they make each year by producing pesticides. So billions of dollars are made each year in the production of pesticides. And again, in the terms of neonics, the ag producers are not seeing benefits with that. chemical producers certainly are. And interestingly enough, these top 4 chemical companies are cornering the market on the sale of these chemicals. So they see this as a extremely profitable business, and they're more than happy to try to corner the market as best they can. And interestingly enough, these same companies are also, at this point, I believe they have about 50% of the market share of seed production for corn and soybeans. So they're buying out the mom and pop seed producers, and so they can force the ag producers to buy their seeds and chemicals on the seeds. Again, when states or countries, for that matter, try affecting change to our pesticide use laws, again, these companies are well-heeled, they got deep pockets, and so they send out legions of different, whether it's lawyers or lobbyists or marketing consultants, that sort of thing. So it's a very tough uphill battle to get for states in particular to affect change in the use of these chemicals. So again, they employ all sorts of marketing strategies, and we can trust those public relations companies, can't we? I mean, back in the 1950s, we can laugh at this advertisement from the 1950s, where again, in the marketing of cigarettes, they had, as you can read here, stating that doctors found that Camel cigarettes are, good for you. You can laugh about that and say, well, this type of marketing doesn't occur anymore. But this is from about 10 years ago now, where, again, the kind of same deal of kind of marketing things that we're told they're good for us or maybe don't have any harm. But I think the reality is something different. But I guess we can't trust Chris Kringle. I'm not certain who we can trust. Anyways, bad joke. Okay. So now I'm going to move on to some of the monitoring work I've done in Wisconsin. I realize it's not directly relevant to Iowa, but it gives you some kind of flavor for what's going on in the environment. So starting back, actually, 2 years before this, I was doing monitoring, but in 2022, I had a pretty rigorous survey, statewide survey in the state of Wisconsin. I used data from some laboratory studies. This paper I cite by Morrissey, what they had done was they took data from 29 different laboratory toxicity studies with aquatic insects, and based on the toxicity values that these individual studies found, they concluded that concentrations of neonics in the water ranging between 35 and 199 parts per trillion was enough to cause chronic toxicity in the aquatic insects. So when I mean chronic toxicity, it's things like changes in their behavior, reductions in growth, reductions in their fecundity or ability to reproduce, their ability to avoid predators, those sorts of things. So it didn't kill the animal directly, but ultimately it has a very significant impact on the populations of these animals. And then when you think about acute toxicity, again, in concentrations in the water greater than 200 parts per trillion, again, that's where we see outright death of these animals over a short exposure period. So the map here, the state, and I did a random sample of 100 stream sites across the state. So the black dots where there's no little bar sticking up, those are sites where there was no neonics detected. Much of that was in the forested north of Wisconsin. But then those taller bars, particularly the red ones, are areas of the state where we're seeing concentrations of neonics that exceeded those toxicity thresholds of 200 nanograms per liter, parts per trillion. So again, point being, in the central part of the state, it's known as the Central Sands region. When the last glacier rumbled through Wisconsin and Iowa, it created a glacial dam and backed up a bunch of water. The dam broke and the water flushed out, but all the sand stayed behind. So that central part of Wisconsin is pool table flat, sandy soil, great place to grow snap beans and carrots and potatoes, vegetable crops where we tend to apply a lot of different types of insecticides. So we're seeing certain parts of the state are super hot as far as neonics are concerned. Again, the concentrations thought to be pretty toxic to aquatic life. So you can read here that some percentage of the streams didn't have any detectable concentrations. Again, about a third of them had this chronic toxicity, so that's pretty significant. And again, this random sample should be pretty representative of the entire state. And then we're seeing, as you can read here, 10% of the survey sites, and again, I can extrapolate that to the state, probably have acute toxicity concentrations of neonics. Again, the Central Sands area notably contaminated, and that off to the east central part of the state, that's where Milwaukee, city of Milwaukee is in Milwaukee County, so a highly urbanized watershed. But in these urban watersheds, we're seeing high concentrations of neonics as well because of their use on golf courses and for ornamental plants and yard care and managing green spaces, that sort of thing. So it's again not just a agricultural issue. And so I'd offer that we took all the streams and rivers in the state of Wisconsin and lined them up, straighten them out, and line them up end to end. It's roughly, as you can read here, 42,000 miles of streams. That's enough to encompass planet Earth 1.7 times. So, no doubt Iowa has probably comparable mileages of streams as well. But for my kind of Wisconsin audience, I can make that case. But again, based on my study results, upwards of 7% of the streams in the state had acute toxicity due to neonics. As you can read here, roughly about 17% had chronic toxicity. So just to put that in perspective, just that 7% or 2,900 miles of streams and rivers with neonic concentrations that are thought to be acutely toxic, that's a distance between where I live in Madison, Wisconsin to Las Vegas, Nevada and back. So that's a significant amount of mileage of streams in the state. And again, if you use that as chronic values as well, like I forget what the analogy might be there, but point being is lots and lots of miles of streams in Wisconsin, and no doubt the rest of the Midwest are impacted by neonics. And just to put this in a context, again, my initial study in 2020 was focused on neonics, and there's 3 of them listed here: this clothianidin, imidacloprid, and thiamethoxam. Those are the primary neonics used in the upper Midwest. But later in that study, the US EPA offered their lab services for a lab in Athens, Georgia. And so again, I sampled 100 different randomly selected stream sites on neonics in 72% of the streams I surveyed, but also we found during the study 135 different pesticides showed up statewide in our streams and rivers. So neonics are a major concern, and rightly so. They're very toxic, highly used throughout the environment. But again, have this recognition that there's a whole alphabet soup of different herbicides, fungicides, and insecticides showing up in streams and rivers, and no doubt that holds true for Iowa as well. And then again, just a map showing kind of where things are popping up, numbers of pesticide-wise. So again, the minimum number of pesticides I found in streams was 9, and the most was 89 different compounds. 89 different compounds in one stream. Again, that was insecticides, herbicides, fungicides, and some growth regulators. So again, just me, a mind-boggling number of different chemicals found at any one stream and river site in the state. And also noted that northern Wisconsin is relatively low development as far as urban development, or agricultural land is pretty sparse in the northern part of the state because of climate issues, primarily in soil types. But even in the forested north, we're seeing detectable concentrations of numerous different pesticides. And you can read here the kind of median number found across the state. Minor point for Iowans, but I point out that because of this laboratory hiccup, the number of pesticides found in urban Milwaukee, as one example of an urban area, is probably much lower, much higher than what's depicted on this map. And so again, the chemical manufacturers are saying, well, these chemicals are extremely safe, much safer than DDT. I go along with that, but again, there's more and more studies showing that it's not just insects that are being impacted by these chemicals, but a recent study done at the University of Wisconsin-La Crosse, they're dosing fish eggs with neonics and seeing what mortality at environmentally relevant concentrations of neonics. So it's not just an insect issue. Since 1970, we've lost, I think, I want to say like 30 billion birds in the United States, or 3 billion, sorry, since 1970. And interestingly enough, the major decline in bird species are those that rely on insects. So, we talk about, what are the causes? Well, no doubt habitat loss is significant. Perhaps climate change is increasingly significant in impacting the birds, but there's some anecdotal evidence that the bird species most strongly affected are those that rely on insects for their food sources. So again, you can read here, again, 200 different species of insect eaters were affected, and a much smaller number of species that don't rely on insects for most of their life. In Montana, probably in about 2015 or so, hunters were seeing abnormalities in the mule deer and white-tailed deer that they were harvesting. So these researchers at South Dakota State University did a study where they had captive deer in an enclosed wildlife area, and they fed them water with environmentally relevant concentrations of neonics. And then this is the findings from what they saw in their effects on that captive deer population. So some abnormalities in the skeletal structure, and then also impacts to their organs, and then increased stillbirths with the fetal white-tailed deer. And so the state of Minnesota kind of followed up on this study, and they asked hunters that share their spleens of the deer they had harvested. And so, as you can read here, in that hunted population, they're seeing concentration of neonics in those wild deer at concentrations that were shown to have caused birth defects in these captive deer. And then they followed up, as you can read here, a couple of years later, they saw even higher concentrations of neonics in those harvested deer organs. So again, the chemical manufacturers, companies said, well, these folks in South Dakota did this study, and it was kind of hokey. They, highly dosed the deer. No doubt they had, no wonder they had health problems or mortality because they used such high concentrations, when in fact these subsequent studies done in Minnesota suggest that, no, actually the concentrations in those deer that were those test deer are very comparable to what we're seeing in the wild. So it's not just an artifact of some lab study or research study. In the state of Wisconsin, the groundwater testing done in the state is showing, one, as you can read here, we have hundreds of thousands of private wells in the state. Those wells tend to be much shallower than, urban wells. So, I think the average probably about a well depth is probably between 60 and 100 feet, where in urban areas, municipal wells tend to be upwards around 300 feet. So the point is they're farther removed from the soils that, where these chemicals are being applied. But again, we're seeing, a significant portion of our test wells, by inference, our rural wells in general are showing concentrations of various pesticides that are concerning, and we don't have regulations on many of these compounds that are showing up in the water. Then moving on to human health aspects, based on data by the CDC, Center for Disease Control, showing that humans are exposed to these chemicals routinely each day, each year, and some other studies done. I don't know these research, but the point is, again, these chemicals are showing up in human bodies. If we're seeing impacts to other mammals like white-tailed deer, and it's one of the few mammals that have been studied. I think we're kind of naive to think, well, yeah, we can get exposed to these chemicals, and it's not going to affect us. Again, we can't be dosing humans. In general, pregnant mothers or pregnant women and fetuses and young, babies are generally most sensitive to chemical exposure. So we can't be dosing our mothers or infants with these chemicals. So we have to kind of rely on a lot of, I wouldn't say anecdotal evidence, but kind of less than rigorous lab studies to make some of these determinations. But again, I think it's cause for concern. Moving into policy issues, again, in Europe, they've banned the use of these chemicals. There's partial bans in 2013, as you can read, that were made permanent in 2018 by the European Union. Canada has been pushing for some restrictions, but there's been pushback by the chemical companies. So they've reversed this national ban, and I'm not frankly certain where they all stand at this point. Interestingly enough, in Quebec, they were able to push through this legislation that farmers had to verify they had a need for the use of a neonics. So you, in essence, had to get a prescription to say, I need these chemicals to protect my crop production. And what they found was that, frankly, the farmers didn't have a real need. And so they stopped using these chemicals in any great amount. And you can see here that the usages have dropped significantly. And again, interestingly enough, there's been no detectable reduction in crop yields by these farmers. So again, the chemical companies are going to tell you, oh, if you don't use these chemicals, you're going to have a pest outbreak in your fields, and sad to you, you're going to lose your crop yields and money for that year. When again, based on results in Canada and some of these provinces, that does not seem to be the case. And then Quebec found these programs so effective, they're actually expanding it to all other insecticides used in that province. So what's happening federally? Again, there's been some interesting work done. The EPA actually reported that based on their studies of where there's endangered species, animal species, that many of those species, I think it's like upwards of 15% of endangered species, are thought to be impacted by the use of neonics. So it's kind of curious that on one hand, the pesticide wing of EPA saying, yeah, these chemicals are safe, or they're under review and we'll get back to you on it. Whereas other arms of the EPA saying, no, based on our understanding of the science, there's some real threats out on the landscape. So I think with the current federal government situation, I suspect this will kind of die a quiet death, at least for a few years. So I'm not certain if things will move forward in a positive manner anytime soon. And again, there's this registration process that's been kind of kicked down the road for a number of years now. So again, I don't see rapid movement on this issue anytime soon. There's been some court cases, whether it's National Resource Defense Council has a few lawsuits in place right now, and where those will end up, I'm not certain. But there's pressures to get the federal government, the Environmental Protection Agency, of all agencies, to kind of do their job, in my opinion. So what's happening in the states? Some states have been enacting some levels of restrictions. Oftentimes it's labeling bans where you can't just go into your Lowe's or name your favorite lawn care or home products big box store, but you can't just go in and buy these things off the shelf anymore in a handful of states. Other states, New York has been pretty progressive. They're trying to ban the use of neonic treated seeds across the board in the state of New York, and in part based on that extensive study done by Cornell University. California's moving forward on a few issues. Again, so there's been a smattering of efforts across the U.S. So maybe there's hope. And if the federal government, in my opinion, is not going to do their job, hopefully states can enact legislation that better protects the environment. So I worked in state government for decades. So let's see, we got off to the right-hand side is Wisconsin State Capitol. Off to the left is the Capitol in D.C. But the point is, I worked in state government for a long time, and I'm not confident the state legislature is going to move forward in an intelligent fashion. I see even less hope at the federal level. So my little kind of take-home message here is that I don't think we can be relying on politicians to move forward in an intelligent manner. So I think this kind of kicks us back into our camp, that we're concerned about this. We're the ones that are going to have to affect change, not hoping somebody else is going to do it for us. I don't know how helpful this is, but certainly when you go to your lawn care product store, you can look at the labels of the chemicals you're buying, and you can see firsthand whether or not neonics are some of the compounds being used in that product. Maybe you'll want to refrain from purchasing those chemicals. And then some other things. if you're buying plants from your home store, some stores, I think Lowe's is one of the first ones to declare that they're no longer treating their plants that they sell with neonics. I'm not certain what other companies may have followed suit, if any. But again, it doesn't hurt you, particularly if you're working through a local nursery or something, to ask them, what is their policy on the use of these chemicals, and maybe if they have enough people asking them the same question, they'll be more thoughtful about where they get their plants from, and refrain from buying treated plants. And I'd also offer that, frankly, on a per volume basis, in our yards, in our horticultural plots, and our ornamental plants, we probably use about 10 times more chemicals on our lawns than we do in our crop fields. So again, I think if we all work individually, intelligently, on how, what chemicals we apply or what nutrients we apply, we can have an effect locally versus thinking this is solely a agricultural problem. So just to reiterate, again, these neonics are widely used, the most widely used insecticide on planet Earth. Again, they're used with pretty strong evidence. There's no value in using them for lots of applications, particularly seed-applied chemicals. Again, some interesting studies done by Cornell University, or compilation of studies done by Cornell University and this other effort in the Midwest, including UW-Madison and Iowa State University and others, showing that there's little evidence that ag producers, particularly soybean and corn producers, benefit from using treated seeds. Again, based on the chemical characteristics, we know these things accumulate in soil, they move in water. And again, based on sampling I've done, and certainly many other people, there's some number of other people, we're seeing acute and chronic concentrations of these chemicals in our streams and rivers. I've done some recent sampling on rural and urban ponds, and it's showing up in ponds, again, wetlands. So I think the more we look for these chemicals, the more we're going to find them in our aquatic environments. So again, I think they're pretty ubiquitous, frankly, in our surface and groundwater, and we need to change that. So with that, I guess I didn't go too long. It's a good thing. If there's time for questions, I'll try to answer them. Otherwise, feel free to, here's my email address. And if you got questions or you want to have some kind of follow-up with me later, I'd be more than happy to try and answer your questions either now or later.
That sounds great, Mike. Thank you. Oh my God, this has been fantastic. If you could stop sharing your screen, and then we could see you a little bit better. And there's a couple people that are going to have to pop off, but I think we have a few questions in the chat box. And if anybody, there's going to be a few people popping off, but I think a few people would like to stay and just ask you a couple more questions. That was just unbelievable. I mean, man, I did pop in a couple of links for the Izaak Walton League. We're one of the oldest organizations that was founded on clean water. We have a Save Our Streams program that's 50 years old, and all about monitoring the streams. And we also just had a recent publication that was in today's Iowa Capitol Dispatch on our nitrate issues, which is a whole nother set of circumstances. But I did pop that in there. And also another link to Carrie Gillum, who is environmental journalist. She's written whitewashed in the Monsanto papers all about glyphosate contamination and the whole story behind that. But she's got an article in there about the cancer listening sessions that have been starting up through Iowa with the Harkin Institute at Drake University and also the Iowa Environmental Council. So I put that link also in the chat. And Chris, are you able to take the questions? Have you been keeping track?
I am.
Okay.
I am. Okay. So Kim Adams asked a good question early on. You talked a lot about the treated seeds, but out here in Iowa, lots of times the crop dusters spray for aphids and so forth. And what do you think they're spraying? Are they spraying neonics?
I mean, that's certainly Neonics are applied topically, as sprays. So I don't doubt for a moment that part of the mix. I'm a stream ecologist. So I kind of on the fringe of my knowledge as far as individual chemical use. I think certainly there's others at Iowa State and elsewhere that can better answer that question. But again, certainly neonics are applied topically to plants, particularly later in the growing season when obviously the crops have emerged and they've leafed out, and maybe that's when there's threats of aphids or whatever. So I don't doubt for a moment, yes, that neonics are being applied, whether that's the primary chemical they're applying or it's a mix of, I assume that primarily insecticides versus fungicides or herbicides, but so I'll leave it at that. I guess I should have, the short answer could have been, I guess I don't know, but I'll leave it at that. Good question.
All right. Okay. And then Dale Braun has a really good question. What, if any, impact do the 135 different neonics have on humans? And have any of these studies that you've looked at been done on humans?
Okay. Well, so to clarify again, these 135 different compounds that is seen showing up in Wisconsin streams were a mix of herbicides, fungicides, and insecticides. So to back up a little bit, there's 5 major neonics that are commercially available, at least in the upper Midwest, that I'm familiar with. And again, and 3 of those tend to show up in the environment. So when I talk about 135 different compounds, again, it's a wide array. So there's certainly not 135 different neonic compounds, but that was kind of the whole universe of detectable pesticides, again, fungicides, herbicides, insecticides, and some growth regulators found in Wisconsin waters. So at that point you can say, oh man, 135 different compounds. You kind of throw your hands up in despair saying, how can we wrap our heads around this? Well, thankfully, the U.S. Environmental Protection Agency has something called ToxCast, so toxicological forecasting. What they've done is there's something called high throughput screening. So what they do is, you may have seen like images or videos of this where they got a machine with like a mechanical robotic arm, and it's got a pipette and it's dosing little cells with chemicals, and they're doing that for, point being is they can test chemicals, thousands of chemicals by looking at how they affect cells or molecules that are thought to be relevant to human effects. So again, the point is, EPA has got some tools that we can, and I've just started doing this, frankly, about 2 weeks ago now, is plug in all that data from hundreds of sites, 100 different compounds of varying concentrations. And again, these statistical tools can help us identify which of the chemicals are thought to be most problematic based on how toxic they are to these cell lines or molecular lines, or the animal tests that are part of this database as well. So again, the toxicity based on those lab and cellular studies, and comparing that with the concentrations we're seeing out in the field. So the point is, there's some tools that can help us wrap our brains around that, but I'm just now kind of delving into that a little bit myself. But that again, at least it gives us kind of a foothold here that otherwise I just throw my hands up in despair and say, hell if I know, I don't know which one of these. I'm not a toxicologist. I don't know all the effects of these hundreds of different compounds, but certainly there are toxicologists that are, and some tools that can help us get at some of those questions.
Well, we really thank you, Mike. I think we probably could go through this again now that we actually have some of this information in our heads, and probably make better notes the next time. I hope Christine will have you back. And for all of you who are still on the call, I know that this recording will be edited a little bit for a short bit, and will be out to you, tomorrow, Christine?
Yeah, I might need an extra day. I'm still trying to catch up, but by the end of the week, definitely it will be on our website. Yep, all of our Watershed Talks are on the website. I put the address in the chat box, our website.
And we'll put Mike's contact information there too, and you'll be able to see his presentation and all of that again.
Yes.
And right.
And I will I just wanted to acknowledge too, so Chris is on the board of the Iowa division, division of the Izaak Walton League. And Dale Braun is our president. He was on here. I think he's still on. Dale, are you still on? There he is. So do you want to say a couple words since this was a pretty significant presentation, and this is what we're all about, is clean water and clean air, clean soil.
Very, very much. Mike, I really appreciate your presentation. Back in the 70s, I worked at a truck stop, and we used to have to, in addition to filling the trucks, we used to have to clean the windshields. And it would take me half an hour sometimes to clean those windshields. Your earlier, earlier picture of monarchs in the grill of a truck are nothing compared to some of the stuff I had to scrape off of the front of those windshields. Today, I drive up to Waverly or somewhere and come back in the nighttime, maybe have a dozen bug hits on the windshield. So it's indicative of what neonicotinoids are doing to our insect population. And so presentations like yours are a way to enlighten the community the impact that pesticides have on our communities. And it starts with things like bees, honeybees, and other insects that birds are living off of. So I really appreciate the information today. Good job.
Certainly, thank you.
Yeah, thank you. And
Those pictures of the mayflies and how many birds they might feed just was amazing. So,
yeah, I love that slide, and Joni Mitchell too.
yeah.
Big Yellow Taxi. That's one of my favorite songs. And okay, well, we'll look forward to keeping in touch. I'm super grateful to Tim Wagner for Tim putting us in touch with you. And he wasn't able to make it tonight, but he was a former agriculture director of Izaak Walton League at the national level. So thank you, everybody, for taking time out to join us this evening, and we'll look forward to sharing our recording, and we will update you on our next presentation soon. We're in the works of our next presentation too. Thank you. Have a
Okay.
great evening, everybody. Thank you, Chris, for co-hosting too.
Thanks, Christine.
Have a great evening, everybody.